All right, our last section on area between curves, and there's just a little twist in this section. So I've got two examples is all I'm going to do. So this is 8, 4, day 3. So our first example, we're going to be finding the area between the curve y equals cosine x and y equals 1 minus cosine x. And we are going to bound it by going from x is between 0 and pi. So I type them in, y equals cosine x, and then 1 minus cosine x, and I set the window to go from 0 to pi, and I'll graph that. And it already did it for me. So if we look, the cosine x I will put in orange. So we'll let this be pi here. I'll end it. And then the 1 minus cosine x appears to do this. So, if you look at my area, it's broken into two regions. I've got the region here, then it crosses, and I've got the region here. Well, if you think about the rectangles that are in here, the area in this first part, when I do top minus bottom, is the orange minus blue, but once I cross this intersection point, now the height of my rectangle switches. It's blue minus orange. So, what happens is I have to do two separate integrals, find the area here, find the area here, and then add them together. And the reason it has to be two separate integrals is because my heights are different for each chunk. So I will have to find this intersection point, and I'll do that right now. Second calc intersection, first curve, second curve, slide that over. So about 1.047. We're starting at 0 because I'm limited to my domain of 0 to pi. So, for area 1, I'll call this area 1, the height at area 1 is orange minus blue. Orange was cosine, minus 1 minus cosine. Distributing, I'll have cosine minus 1 plus cosine, which simplifies to 2 cosine x minus 1. Now for area 2, well, the height of my rectangle is blue minus orange. So that'll be 1 minus cosine, that's the blue, minus the orange is cosine. Simplifying, I get 1 minus 2 cosine x. So now to get the total area, we'll do this first chunk, which is the integral from 0 to 1.04, 7. And my height is 2 cosine x minus 1 dx. And we're going to add the second chunk, which goes from starting at 1.047 and finishing at pi. And that height was this one here, 1 minus 2 cosine x. So now we just do antiderivative. This will be 2 sine x. Sine's derivative is cosine, and then antiderivative there will be x. And we'll go from 0 to 1.047. Here, x minus 2 sine x from 1.047 to pi. And I have those in this one. Yep, I already put them in. 2 sine x minus 1 is my first one. I'll just shut this second one off. And I want 1.047. Got it. 1.6849 minus, putting in 0, I get 0. And then over here, I'll turn this one off. I've already got it typed in to save time. I need the I need the pi first. Pi 3.1416, that is pi, minus, put in that 1.047, and I get a negative 0.6849. So now let's just add all of that together. So I got 0.6849, I got 2 of those, plus the pi that I had there in the middle, 4.5114. So, a little different in that we had to do it in parts. And same thing on this next example, except it's not quite as obvious where they actually cross and switch over. So, number 2, didn't look to make sure that was there for everybody. I think so. Number 2, our equations are y equals 3x squared, y equals 8x squared, 4x plus y equals 4, and we're going to have x be greater than or equal to 0. Okay, I'm going to get this one calculator ready by subtracting the 4x. So y equals 4 minus 4x is what I can type in. Not that one. Okay. I'll start this over so you can see everything I did. So I got 3x squared, 8x squared, and 4 minus 4x. Parabola, skinnier parabola, and a line. Looks like it's really clustered up here. But remember, x has to be greater than 0, so I'm only looking at this first quadrant here. So I'm going to change my window and have the minimum be 0 for x. And I know it was all up in the first quadrant. I'm going to have the minimum y be like -2. I'm going to regraph that. So the area that's bounded by all 3 of these is right in here. So I will graph. So y equals 3x squared was that parabola. I'm going to exaggerate it. Y equals 8x squared is also a parabola, but it's a little steeper. It's dried out on me. And then I have the line coming through. Okay, looks like it's just one region. It's this region right here. That's bounded by all 3 of those. But if you think about drawing your rectangles in here, let's go with this. When I start out, the height of my rectangles are all blue function minus orange function. Blue function minus orange function until I get to this intersection. Once I cross over, now when I draw a rectangle, it's the line minus the orange function. So this really is has to be done with 2 pieces. I have to chunk it up right at this intersection. Imagine a vertical divider here. So that on the first area, it's blue function minus orange, and then in the second area, it's line minus orange. So I'm going to have to go from 0. I have to find the intersection of the line, and this was the 8x squared. So I can do that. I'm going to go second, calc, intersect. And it's asking me, is this what you want to use as your first curve? Because usually we only have 2 in here, but this time I've got 3. And right now it's saying, is y1, the 3x squared, what you want to use? And it's not, so I'm going to make it scroll by using the up arrow, it jumped to the line. I'm going to hit enter. Now it's still on Y1. I'm going to get it to Y2 and hit enter. And then I will get close to that intersection coming in. Oh, here it is. Enter. X value is a half, so it's crossing at a half. And then I've got to find this intersection, which is the line and the 3x squared. So calc, intersect again. I want to use the 3x squared. And then I want to use the line. And I see them changing up at the top here. And 0.6 repeating is 2/3. So I've got my intersections. I have two different heights to work with, so I'll call this area 1. The height of my rectangles there is blue function minus orange function. Blue was the 8x squared. Orange was the 3x squared. That will simplify to 5x squared. So this is area 1. Now when I jump over to area 2, my height is the linear function and then minus orange. So 4 minus 4x. Orange was the 3x squared. And I can't do anything there. So now, to get my total area, I have to do it as two separate integrals. The first area goes from 0 to 1/2 of the 5x squared. And then the second area is going from 1/2 to the 2/3, and it's this height here. So again, it's just a 2-in-1 problem, and you have to pick up on the fact that as you draw rectangles through the whole shaded region, the equations switch at that intersection there. So now just antiderivative, so this will be add 1 times by reciprocal from 0 to 1/2. Here, antiderivative is 4x. This will go x squared, divide by 2. 2x squared. This will go 3, divide by 3. Okay, and I don't think I'm going to take the time to plug all that in. The important part of this one was realizing you had to do it in 2 pieces. So you will have a couple on the next homework assignment that have to be done in chunks.